In 1928, a pound of cemented tungsten carbide cost $48. It was the hardest cutting material in industrial production, and it could machine steel at speeds that would destroy any high-speed steel bit in seconds. So General Electric and Germany's Friedrich Krupp signed a 15-year pact to control every gram of it on Earth. Within a few years, the price hit $453 a pound. The actual production cost was between 6 and 12 cents per gram. They were charging $1. And every machine shop in America that could have been running carbide was stuck on high-speed steel instead, because two corporations decided the future of metalworking was too profitable to share. They were getting away with it too. Until a metallurgist in Latrobe, Pennsylvania, invented something they couldn't patent their way around. If this is the kind of history that belongs on your shop wall, you're in the right place. Hit subscribe to Trade Archive and drop a like so we can keep telling these stories. To understand how one man broke an international monopoly, you have to start with the family that raised him. Philip McKenna was born on June 16, 1897, in Pittsburgh, Pennsylvania, into a household where metallurgy was closer to a religion than a profession. His father, Alexander G. McKenna, was an alloy steel pioneer who had developed an 18% tungsten tool steel around the turn of the century, a composition that raised cutting speeds from roughly 26 feet per minute to 99 feet per minute. The McKenna family's roots in the metal trades ran back to 1832, when Philip's grandfather, an Irish coppersmith named Robert McKenna, arrived in Pittsburgh and founded the McKenna Brothers Brass Company. By the time Philip was 7 years old, he was stoking his father's blacksmith forge and watching drill steels being heat-treated. By 15, he was working alongside chemists. By 18, in 1915, he already held 2 registered patents, one for a method of extracting tungsten values from ores, and another for a process that separated cobalt from nickel. He was a working professional chemist before he was old enough to vote. McKenna enrolled at George Washington University in Washington, D.C., studying evenings so he could spend his days doing research. He had already worked as an assistant in the iron division of the U.S. Bureau of Standards in 1914, and he continued that pattern through college, graduating with a bachelor's degree in 1921. He later attended Columbia University as well. But it was back in western Pennsylvania where his career would take shape. In 1910, the McKenna family had organized the Vanadium Alloys Steel Company, known as Vasco, in Latrobe, a small railroad town about 40 miles southeast of Pittsburgh, in the foothills of the Laurel Highlands. In 1928, Philip moved to Latrobe to serve as Vasco's research director. For the next decade, he dedicated himself to solving the single biggest productivity bottleneck in American machining: how to cut steel faster, harder, and longer without burning through tooling. McKenna spent years experimenting with cemented carbide compositions, searching for a formulation that could outperform anything on the market. In December 1937, he filed a patent for a novel tungsten-titanium carbide alloy. It was granted on April 5, 1938, as United States Patent 2,113,353. The material was described in the filing as much harder than the hardest tool steel. McKenna called it Kennametal. Earlier that year, he had resigned from Vasco after a bitter falling out over the Vascaloy-Ramet joint venture, a troubled carbide project that had suffered chronic mismanagement and quality failures so severe that Chevrolet's auto body division rejected 1,200 tools in a single batch. McKenna was done working for someone else. In September 1938, he formed the McKenna Metals Company as a sole proprietorship in Latrobe, with roughly a dozen employees and a product he believed could change the metalworking trade forever. Latrobe was a good place for a man like McKenna to start a company. The town had been laid out in 1851 by a Pennsylvania railroad engineer named Oliver Barnes, incorporated in 1854, and named for railroad surveyor Benjamin Henry Latrobe II. By the 1930s, it had become a center of alloy steel production. Latrobe Electric Steel, founded in 1913, was already manufacturing specialty steels and tool steels just down the road, the kind of steels that McKenna's carbide tools were designed to cut. The town's economy ran on metallurgy, the way a farming town runs on soil. It produced Arnold Palmer, Fred Rogers, and Rolling Rock beer, but its real product was alloys. McKenna's workshop sat in the middle of a community that understood what he was trying to do, because half the people in town worked with metal for a living. He was right about the product. What he didn't fully appreciate yet was the fight he was walking into. The global cemented carbide market in 1938 was not a free market. It was a cartel. General Electric, through its subsidiary Carballoy Company, and Friedrich Krupp AG of Essen, Germany, had signed a sweeping agreement on November 5, 1928, that divided the entire planet between them. Under the terms, Krupp agreed to stop exporting cemented carbides to the United States. In exchange, GE agreed not to export without Krupp's written consent. They cross-licensed their patents, pooled their intellectual property, and systematically crushed or absorbed any independent competitor who tried to enter the business. GE deliberately limited the number of American licensees. Krupp controlled Europe. Together, they controlled the price. And the price was obscene. When GE first commercialized cemented carbide through Carballoy, it set the price at $453 per pound, or $1 per gram. William G. Robbins, Carballoy's own president, later admitted under oath that the production cost at the time was between 6 and 12 cents per gram. That meant the markup was somewhere between 8 and 16 times the actual cost of manufacturing. For every machinist in America, this had a direct and painful consequence. A carbide-tipped tool could be used 1,000 times before it needed regrinding. A conventional tool steel cutter lasted about 100 operations. Carbide was a leap in productivity that every shop needed and almost none could afford. The foreman who wanted to run carbide inserts on his turret lathe was paying $1 a gram for something that cost a dime to make, and the cartel wasn't just inflating prices, it was restricting supply. GE deliberately limited the number of American licensees who could manufacture or sell cemented carbide products. If you weren't on their list, you didn't buy. Shops that wanted the productivity gains of carbide tooling were stuck running high-speed steel at lower feeds and speeds, wearing out cutters at 10 times the rate, and losing money on every part cycle. The cartel made sure of that. When McKenna's tungsten-titanium carbide hit the market, it bypassed the Krupp and Carballoy patent portfolio entirely. His composition was different enough that their intellectual property couldn't touch it, and his prices were competitive. The cartel responded the way cartels do. They tried to pressure him, absorb him, and intimidate him into licensing agreements that would have folded his company into their structure. McKenna refused. The consequences of the monopoly had drawn the attention of the United States Senate Patents Committee, which held hearings in April 1942 condemning the artificial shortage. John Henry Lewin, a special assistant to the Attorney General, testified that the present drastic shortage of this essential material in this country is notorious, and called it one of the principal bottlenecks in our production program. At those same hearings, Carballoy President Robbins leapt to his feet and declared, "I refuse to be called un-American or that our company is un-American." On October 21, 1941, the Department of Justice returned a criminal indictment against General Electric, Carballoy, and their officers, charging violations of the Sherman Antitrust Act and the Wilson Tariff Act. The prosecution was suspended during the war, but the case was eventually tried before Chief Judge John C. Knox of the Southern District of New York. In 1948, Knox issued his verdict. He wrote that competitors were excluded by purchase and by boycott. Prices on unpatented products were fixed. World markets were divided. General Electric and Carballoy were found guilty. The fines were $20,000 each. The individual executives paid between $1,000 and $2,500 apiece. The penalties were a slap on the wrist, but the monopoly was broken, and the market that Philip McKenna had forced open with his patents was now legally free. The mainstream press barely covered the trial. Almost the only journalist who reported on it in detail was James Lerner of UE News, the paper of the United Electrical, Radio and Machine Workers of America. The story of how one of the largest industrial cartels of the 20th century was dismantled played out in near silence. But McKenna didn't need headlines. He needed orders. And by the time the cartel case went to trial, his company was already deep in the business of winning a war. The McKenna Metals Company had started in September 1938 with about $30,000 in first-year sales. In 1940, Philip brought in his cousin Alex and his brother Donald as partners. By 1941, the first major international order arrived through the Lend-Lease Agreement between the United States and Great Britain. Contracts followed from the Chrysler Tank Arsenal and the U.S. Steel Export Company. Sales hit $999,000 by the end of fiscal 1941. The dozen-man shop in Latrobe was suddenly a strategic supplier. During World War II, Kennametal's carbide tools became essential to the Allied production effort. The scale of wartime manufacturing was unlike anything the industrial world had seen. Every tank tread, every aircraft engine cylinder, every artillery barrel required precision machining of hardened steel, and the production schedules were brutal. Factories that had been running single shifts went to 3. Machines that had been pacing themselves on commercial tolerances were now running flat out on military specifications. Carbide tooling was the only way to hold those speeds and feeds without burning through cutters faster than the supply chain could replace them. The shops that had carbide could keep pace. The shops that did not were the bottleneck. But Kennametal's contribution went beyond cutting tools. The company developed a process to manufacture tungsten carbide penetrators, the hardened outer cores of armor-piercing shells designed to punch through the heavy plate of German tanks. These were not accessories. They were munitions. The carbide core had to be harder than the armor it was hitting, and it had to survive the impact forces at muzzle velocity without shattering before it penetrated. Kennametal was making them in Latrobe, shipping them to ordnance plants, and watching them leave the country in the holds of transport ships. In 1943, Philip McKenna dissolved the family partnership and incorporated the company as Kennametal Incorporated. Revenue had reached $7.5 million. The little proprietary shop was now a wartime industrial operation feeding the largest military mobilization in history. When the war ended in 1945, the defense contracts vanished overnight. Kennametal pivoted. And what came next would matter just as much to the average machinist as anything the company did during the war. In 1946, Kennametal introduced the Kendex system, a line of mechanically held, precision-ground, indexable carbide inserts. If you have spent any time on a lathe or a milling machine, you understand what this meant. Before indexable inserts, carbide cutting tools were brazed onto steel shanks. When the edge wore out, you pulled the tool, sent it to be reground, and waited. Regrinding was a skill in itself. You needed a good eye, a steady hand, and a diamond wheel, and even then, the reground geometry was never quite the same as the original. Every regrind changed the rake angle slightly, changed the chip breaker profile, changed the way the tool cut. Two supposedly identical tools could perform differently because one had been reground 3 times and the other 6. Meanwhile, your machine sat idle, your spindle was cold, and your parts were not getting made. The Kendex system changed that equation entirely. A machinist could now loosen a clamp screw, rotate the insert to a fresh cutting edge, re-tighten, and be cutting again in under a minute. When all the edges were spent, you threw the insert away and dropped in a new one. The geometry was consistent from insert to insert because they were precision ground at the factory, not hand-dressed on a bench grinder. The mechanical clamping meant no brazing, no thermal distortion from the torch, and no risk of cracking the carbide during the brazing process. The tool holder lasted indefinitely. Only the insert was consumable. It was the beginning of the throwaway insert era, and every indexable carbide system used in modern machining, from the simplest CNMG turning insert to the most complex milling cutter body, descends from that concept. The Korean War brought Kennametal back to defense work. The Department of Defense contracted the company to produce 190,000 armor-piercing tungsten carbide penetrators. By 1954, annual sales had climbed to $24 million. In 1958, Kennametal created the Kennametal Overseas Corporation to formalize its international expansion, establishing affiliations in Italy and joint ventures in Britain, planting the flag in markets that had been Krupp's territory a generation earlier. Philip McKenna died on August 16, 1969, at the age of 72. He had spent the last decades of his life as a Fellow of the American Association for the Advancement of Science and was honored as the American Society of Mechanical Engineers Town Lecturer in 1953. His signature belief, repeated often enough to be remembered, was this: when it comes to making new and useful things, we are just starting to realize the possibilities. Outside the lab, he was consumed by monetary policy, serving as national chairman of the Gold Standard League from 1949 to 1955. The contractor who decades later restored his home in Unity Township, a house McKenna built in 1929, said that every rafter was perfect, every floorboard was perfect, with no twist anywhere in the structure. It was the house of a man who engineered everything, even where he slept. After his death, Alex McKenna stayed on as president and chief executive officer. Donald McKenna became chairman. The company remained in family hands, and it continued to grow. But the next chapter of Kennametal would not be written in Latrobe alone. In August 2002, Kennametal completed the acquisition of the Widia Group from Cincinnati Metalworking for €188 million, roughly $170 million. Widia at the time employed about 3,400 people, operated 10 manufacturing facilities across Europe and India, and pulled in approximately $240 million in annual sales. The brand name came from the German phrase wie Diamant, meaning like diamond. And here is an irony worth pausing on. Widia was originally a Krupp product. Friedrich Krupp AG registered the Widia trademark in Germany in 1926 and first used it as a cutting tool brand in 1927. The company that broke the Krupp carbide cartel had now bought the Krupp carbide brand. Philip McKenna had been dead for 33 years, but he would have appreciated the symmetry. 3 years later, in March 2005, Kennametal acquired the Extrude Hone Corporation of Irwin, Pennsylvania, for approximately $137 million. Extrude Hone was the creation of Lawrence Rhodes, a machine tool visionary who held more than 25 patents and later pioneered commercial metal three-dimensional printing. His signature technology was abrasive flow machining, known as AFM. The process is unlike anything else in a machine shop, and once you understand it, you never forget it. The workpiece is fixtured between two opposed hydraulic cylinders. A putty-like polymer medium, loaded with silicon carbide or aluminum oxide grit in a precisely controlled grain size, is forced back and forth through or across the internal passages of the part under pressures that can exceed 1,000 pounds per square inch. The medium conforms to every contour, every rib, every cooling hole. Each pass removes a controlled amount of material, uniformly smoothing surfaces that no end mill, no hone, and no hand tool can reach. The result is a mirror-quality finish on internal geometries that were previously left as cast or as machined, with the burrs and tool marks still in place. The applications are the kind that keep aerospace quality engineers up at night. AFM machines polish the internal cooling passages of turbine blades, where surface roughness directly affects airflow efficiency and fatigue life. They finish the fuel injector bodies in diesel and gasoline engines, where bore geometry at the micron level determines spray pattern and combustion efficiency. They deburr the cross-drilled intersections in hydraulic valve bodies that would otherwise trap chips and cause catastrophic failures in flight. The technology became so dominant in its niche that extrude honing appeared as a verb on OEM engineering drawings. Rhodes died unexpectedly in 2007 while on vacation in Hawaii. Kennametal would eventually divest Extrude Hone in 2015, selling it to Madison Industries. In 2012, Kennametal added another piece. The Deloro Stellite Group, acquired for approximately €277 million from the British private equity firm Duke Street, brought a legacy of cobalt-chromium superalloys that traced back to Elwood Haynes's first stellite patent in 1907. Stellite was one of the earliest engineered superalloys, designed to resist extreme heat, corrosion, and abrasive wear in environments where ordinary steels would melt or erode. The Deloro Stellite manufacturing plant in Belleville, Ontario, had roots in a gold smelting operation in the village of Deloro, which had been producing stellite alloys since around 1912 before relocating operations to Belleville between 1956 and 1972. For the workers who ran that plant, stellite was not an acquisition target. It was a trade. Many of them had spent their entire careers pouring, machining, and inspecting cobalt alloys in that building on Dundas Street East. The plant was a cornerstone of the local economy and had a labor history that stretched back decades. This fact would matter very soon. Kennametal's tooling is made by powder metallurgy. Tungsten carbide powder is blended with a cobalt or nickel binder, milled to a precise grain distribution, then pressed into green compacts or extruded as rod. The green parts are sintered at high temperature, where the binder metal liquefies and cements the carbide grains into a dense, near-diamond hard matrix. After sintering, the blanks are ground to final geometry using diamond wheels and then coated, typically by physical vapor deposition or chemical vapor deposition processes, with wear-resistant layers like titanium aluminum nitride. The Latrobe Technology Center still produces tungsten carbide powder using thermite and carburizing methods. The Rogers, Arkansas plant makes carbide rod blanks for the aerospace and defense supply chain. But as Kennametal expanded into a global operation spanning nearly 100 countries and more than 8,000 employees, the friction between corporate optimization and the people on the factory floor became impossible to ignore. The Belleville, Ontario plant that came with the Deloro Stellite acquisition had enjoyed 60 years of uninterrupted labor peace. Since 1957, there had been no strike and no lockout at that facility. The United Steelworkers Local 5533 and the company had renewed contracts for decades without a work stoppage. Then Kennametal arrived. In June 2017, the company came to the bargaining table demanding concessions on wages, benefits, and mandatory overtime. The union membership responded with a 96% vote in favor of a strike mandate. Local President Bert Defoe told the press that his members were shocked. Marty Warren, the USW's Ontario director, framed the situation plainly, saying Kennametal was threatening to tear down what 60 years of workers had built. A separate strike did occur in 2024 over wages and was resolved with a 3-year deal that included a 4.5% raise in the first year. But the damage to the relationship was already done. 2 years after the Belleville crisis, a similar confrontation erupted in Greenfield, Massachusetts, at a facility with even deeper union roots. The Greenfield plant had been organized under UE Local 274 since 1941, the same year Kennametal landed its first Lend-Lease contract. In August 2019, roughly 65 workers walked off the job in a 3-day warning strike. The issue was healthcare. Kennametal wanted to eliminate the union's existing healthcare plan and replace it with a high-deductible plan while reserving the right to make future changes without bargaining. They also demanded mandatory overtime and the ability to replace union positions with temporary workers. The UE's Northeast Region president stood on the picket line outside the Greenfield tap and die plant and said that workers here bust their backs to give a good product to this company, and the company wants to break their backs by taking every penny they can from them. Another union member was more direct. He said they had had a contract for the last 80 years and would do everything they could to protect it. He added that all of their blood and sweat had gone into the tap and die, and they were not going to be treated that way. Kennametal designated the Greenfield facility for closure. It was shut down in fiscal 2025 as part of the company's global footprint restructuring. The labor disputes were one reckoning. The environmental record was another. For decades, the industrial processing of tungsten and cobalt generated hazardous waste that was handled the way most heavy metal waste was handled in the 20th century, which is to say, badly. The Li Tungsten Superfund site in Glen Cove, New York, a former tungsten processing facility that had refined material for the wartime defense effort, was placed on the EPA's National Priorities List in 1992. The site was heavily contaminated with heavy metals and radioactive slag. In February 2007, the Department of Justice and the EPA announced a settlement naming Kennametal alongside General Electric, Sandvik AB, and several other corporations as potentially responsible parties that had arranged for the disposal of materials at the site. The cleanup was extensive, and the settlements ran into the tens of millions of dollars. Kennametal has since made a visible pivot toward environmental responsibility. For the fifth consecutive year, the company was named to Newsweek's list of America's most responsible companies in 2026, evaluated across environmental, social, and governance criteria by Statista. The company's modern sustainability reports document year-over-year reductions in greenhouse gas emissions, decreased water withdrawal, and a 10% increase in waste recycling. Their carbide recycling programs have become a cornerstone of the circular economy within the tooling industry, reclaiming tungsten and cobalt from spent inserts and worn tooling to reduce dependence on virgin mining operations. The innovation that Philip McKenna started has not stopped. In recent years, Kennametal has used additive manufacturing to build a 3D printed stator bore tool for electric vehicle motor housings. The conventional version of the tool would weigh over 25 kilograms, too heavy for most machine tool changers. The 3D printed version, equipped with a KM4X adapter and internal cooling channels printed directly into the body, weighs roughly 10.5 kilograms. A similar project for electric vehicle manufacturer Voith produced a transmission housing tool that cut weight by 45% and reduced machining time by half. These are not concepts, they are running in production. Philip McKenna started with a forge, a patent, and a dozen employees in a small town in western Pennsylvania. He fought an international cartel backed by the largest electrical manufacturer on Earth and the largest arms maker in Germany, and he won. His carbide helped pierce the armor of German tanks. His indexable inserts ended the era of regrinding and changed the workflow of every machine shop that adopted them. His company survived him, grew into a global operation, absorbed competitors and allies alike, and grappled with the consequences of its own expansion, in union halls and on Superfund sites and in the lives of workers who gave decades to the trade only to watch their facilities close. Kennametal today operates in nearly 100 countries, employs more than 8,000 people, and continues to push the boundaries of what carbide, ceramics, and engineered coatings can do. The company has outlived its founder, outlived the cartel that tried to stop him, and outlived the century that produced both. Whether you're running Harvey end mills in a 5-axis aerospace cell or swapping Widia inserts on a knee mill in a job shop, the tools in your hands trace back to a metallurgist who believed, in his own words, that we are just starting to realize the possibilities. He was right. And 88 years later, the trade is still proving it. If you want more stories like this one, the next video on screen goes deeper into another company that shaped the way things are built. Click it now while it's fresh.